On the far side of the planet lies one of the most remote and inhospitable places on Earth. Elephant Island, situated just off the tip of the Antarctic Peninsula, is a rugged landscape of cliffs and glaciers shaped by brutal winds. It's also home to vast colonies of one of Antarctica's most iconic animals. Supported by environmental organization Greenpeace, a team of scientists lands on Elephant Island. For the first time in 50 years, they will investigate how its penguins are faring. The health of the Antarctic ecosystem is linked to the state of penguin populations. And the best way to measure those is by counting the birds.
So we're counting penguins, and why do we count penguins? Well, penguins are great bioindicators, and they'll tell us what the health of the ocean around Antarctica is because they eat krill. Krill eat phytoplankton, so we can tell indirectly what the productivity of the oceans around here, how it's responding to environmental change. And so we can't really adequately count the phytoplankton. It's really difficult to count the krill. But we can count penguins because they come ashore every year to these same places to breed, and we're getting some idea about how the ocean is performing by how penguin populations change over time. And we go nest by nest. We're counting nests because we want to know what the breeding population is. We're not interested in all these penguins that are roaming around that you see kind of wandering about here. A lot of those are non-breeders. They just come here because there's a lot of penguins, a lot of activity. We want to know what the size of the breeding population is because that's what's going to make new penguins for the future. And those are the most sensitive parts of this population.
There are multiple penguin species on Elephant Island, such as the gentoo with their distinctive orange beak, the flamboyant macaroni penguin, and even these towering king penguins carefully shuffling across the island.
Michael.
The researchers record all penguins, but are mainly interested in chin straps, so called for the narrow black band on the underside of their heads. The chin straps are the noisiest and most numerous penguin on the island. And since weather conditions here are not always suitable for field work, the race is on to find out exactly how numerous the chin straps still are.
There's 4 of us penguin counters. One person says, okay, I'll take the high point up to the right. One person says, I'll go up high to the left. One person, that's me today, starts down low, and we'll work our way up, and then we all meet in the middle. And it's important to divide it up like that so that we can be sure not to be counting the same penguins twice.
It's January, which means the height of Antarctic summer. With 1 or 2 chicks to each nest, the colonies are dense packs of shrieking and pecking birds, which makes moving around a delicate affair.
Normally we don't try to walk through the colony because it's so dense, but here there's just no free space in between the penguins. So very carefully, you try to step on the high stones between the birds and obviously not get too close to their nests if you can. Counting penguins at its core is pretty basic. It really is 1, 2, 3. We actually count them all 3 times to try to get a count that's within 5% error. It kind of looks crazy sometimes. We're standing on a rock gazing over a penguin colony, very still, with our arms out. And it looks like we're conducting a symphony of penguins or something like that because we're out there really looking at every single individual penguin and literally counting heads. And if there's only 10 penguins in a colony, it's pretty easy. If there's 100, you can get through them. If you're surrounded by 1,000 penguins in one big blob, that's what I would call advanced penguin counting.
But some colonies are over 10,000 individuals, and chin straps love to nest on steep and exposed cliffs that are hard to reach on foot. So to count all of these flightless birds, your best bet is to take to the air.
So when we get to colonies that are so big that it's almost infeasible to count by hand. We use aerial surveys. The idea is to capture all colonies with aerial images so that we can either use a manual count or a machine learning algorithm to do the counts for us. When we arrive at a site, we do a quick lay of the land where the different colonies are, and then we pick out a system where we can make sure that we don't miss any of the colonies. So we start at a logical point and set up a grid survey with GPS locations of the boundaries of the colonies, and then we launch the drone and have it run the grid patterns. And at that point, it's pretty hands-off. It flies to the first point and heads to the series of waypoints, and the drone is able to take photos every 2 seconds. And that's how we can get a set of images with a decent amount of overlap that can be used in the next step, which is photomosaicing. Once it finishes the whole survey, we retrieve it, and that's how we can finish a site and then walk over to the next area, and so on.
For a bird nerd like me, being in the middle of a penguin colony here in a practically unexplored island in Antarctica is like the ultimate experience. I can't even describe it. It makes my skin tingle when we're on the Zodiac and we're coming into the beach, just seeing all these birds waiting for us to arrive. Penguins. They're so easy to empathize with because they act like people in so many ways. They have all these curious behaviors. They run around. They're always on a mission, up to something. They're very energetic. They're charismatic. Penguins are really amazing creatures. They are hardcore, and they have some pretty amazing adaptations to survive here. They have the densest packed feathers of any bird in the world. It's something like 90 feathers per square inch. That gives them their waterproof parka and down jacket all in one. They spend a lot of their time swimming. They can swim for months at a stretch without stopping. They sleep on the ocean. The only reason they ever come to land at all is to build a nest, and then they go and spend the rest of their lives actually in the ocean, offshore. And to be an animal that only exists in the Southern Ocean for months at a time, just swimming around, finding the fish and krill that they need to eat, that is hard for us to imagine and comprehend, and that I think is partly why it's so fascinating for us to see penguins down here. I think that we can learn a lot by watching birds, because birds at their core need most of the same things that we do. They need a place to live, they need food, they need to find a mate and leave a legacy. I think that also birds experience all kinds of similar emotions and thoughts and feelings. So I think by coming out here and doing these studies, it's almost like we're looking at our own behavior through the prism of another species, and that gives us a license to take a step back and say, oh yeah, okay, that's what's really happening.
Penguin colonies may remain in place for centuries and chin straps, even though they venture out to sea for hundreds of miles, always return to the same colony to breed. The last and only time Elephant Island's penguin population was properly surveyed was in 1971. The maps and data from that British Joint Services expedition are now being used by the present-day researchers.
So we've got some great data from 50 years ago about what the penguin populations look like. So we'll compare our counts to that historic data, and we'll get some idea about whether things are changing or not.
Penguins are extremely well adapted to live in Antarctica in these conditions. But when those conditions then start to change, that's when we start getting worried about them, because they've evolved over so many eons to live in this place as it is, and then as it starts to change, then we'll see how adaptable the penguins can be.
The Antarctic is witnessing vast changes. Over the past 50 years, temperatures have risen by around 3 degrees centigrade, one of the fastest increases in the world. Among other things, the warming affects ice formation. And the underside of sea ice is a critical habitat for krill, the shrimp-like creatures which are food for many of Antarctica's animals, including chinstrap penguins.
The climate change losers here are chinstrap penguins. Everywhere else we go on the peninsula, we're seeing chinstrap declines over the last 50 years, and it's been dramatic. Some of those populations have declined as much as 50%. We've seen chinstrap colonies completely vanish.
A changing climate is not the only threat to chinstraps. In recent years, krill fishing has caused competition for their food, creating additional pressure on the penguins in ways we are yet to fully understand. After 10 days of counting and covering 98% of the colonies surveyed in 1971, it's time for the researchers to add up the results.
44, 45, 45, 16 three times.
All of Elephant Island's 32 colonies show declines, and overall the chinstrap population has fallen by almost 60% in 50 years.
11 three times. We try to keep an impartial look at this in terms of our emotional response to the data. It's disturbing from the standpoint of the amount of change that's happening so rapidly. We just don't see this kind of stuff in other ecosystems generally. If you'd seen this with, say, any terrestrial mammal species over a 50-year period, people would be certainly concerned. It suggests the amount of change that's happening here, how rapid it is. And it remains to be seen what the ultimate consequences are, not just for chinstrap penguins, but for the ecosystem as a whole.
If you removed all the penguins from Antarctica, what would happen? I don't want to do that experiment as a scientist or as a person who loves birds. Penguins are a keystone in Antarctica. There's something like 90% of the avian biomass in this region is penguins, and there are millions and millions of them. We are seeing some worrying declines in their populations. So right now I'm not so much worried that the chinstrap penguin is going to go extinct as that they're telling us that something in their larger ecosystem is broken in some way, and that the changes in their populations are reflecting that.
I've been coming down here for 25 years, and I've seen some pretty remarkable changes. Been seeing penguin populations crash, literally. Climate's changing more rapidly in the Antarctic Peninsula probably than any place on the planet. It's very likely that when we experience these things in our temperate climates where we all live, we're also going to have to adapt, just as the chinstrap penguins are doing right now. So it's a lesson for us, because we either are going to heed this example that we're seeing down here in the Antarctic, or we won't. And we'll suffer the consequences, just as, unfortunately, the chinstrap penguins seem to be doing down here. They don't have a chance to control their environment. They're stuck with whatever we hand them, but we have the ability to change, and we should take serious measures to do so.
Antarctica has always been a continent that has challenged us. Now its challenge is for us to leave it unharmed and establish large-scale protection for those living on the edge.